Hey, today we're going to be solving LeetCode 1372, and this is the longest zigzag path in a binary tree. So let's get started by reading the problem. We are given the root of a binary tree, pretty standard, and a zigzag path for this binary tree is defined as follows. So we're going to choose any node in the binary tree to start with, and we're going to choose a direction, which since it's a binary tree, we only have left or right. And if the current direction is right, we need to move to the right child of the current node, otherwise we move to the left child. And we're going to change direction from right to left or left to right, and we're going to repeat these steps until you can't move in the tree. So I think this description is a little bit too wordy. I kind of get that it needs a formal definition, but essentially what you want is you want a path that starts and ends anywhere, and it keeps alternating in direction for which child you take. So for example, in this one, it's kind of clear that the longest zigzag path is outlined in red. We're going right, left, right, and we're going to get a path length of 3. As for why it doesn't start the root, well, we have to go right twice, so we can't include this in our path. We also can't include this down here because that would violate the rule of zigzagging. So we can solve this in a recursive manner, and let's take a look at how we're going to need to look at the problem from a recursive standpoint. So imagine we have this tree right here. It's actually important to note that the values of the nodes don't matter, so I just left them blank. So say we're at this root node. We want to know what is the longest zigzag path, right, for the two nodes that we're going to recurse to. So let's recurse to the left. And now it's important to note that we have taken a left. We have chosen a direction. We've chose to go left from the original node. And now for our left one, what we could choose to do is we could either extend this path by going right, or we could restart, right? And actually start from here and go left. We can't go left twice. So we have two options, right? For any particular node. If the previous pointer we took was to the left, we have to either go right to extend the path, right? Or we have to restart and go left. And the same thing with right. I haven't drawn them out here, but let me just add 2, right? If we have gone right to this node, we can either go left to extend the path, or we can restart the path and go right. So that's going to be the crux of our solution. Really, all we have to worry about here is just getting some base cases dealt with and something like that. There's actually a pretty simple solution that only involves a couple lines, but just for the sake of clarity, I'm going to make it a little bit more verbose and a bit longer than normal, and then I'm going to condense the code into a shorter version. So what we're going to want to do is we're going to define our depth first search, right? That's what we're going to use to iterate here. So what it's going to do is it's going to take the current node, right, which is a tree node. It's going to take previous, which is going to be a string. Previous is either going to be L, meaning the previous pointer we took was to the left, or R, the previous pointer we took was to the right. And then for here, for lastly, we're just going to have the current length of the path. This is important because we need to be able to reset the path at a given point, right? If we need to go left twice or right twice. And what it's going to return is an integer, and it's going to be the length of the longest zigzag path starting from this node. And it doesn't have to actually use this node, it's just starting. So everything below. And we are going to recurse up, so every time we're going to build our answer while going up. So what we're going to do for our base case is if we have a null node, we're just going to return the length, right? We have found the end of the path, and so we're just going to return the current length and have that be that. So now we need to increment the current length by 1 because we're visiting a new node, right? And now we have two options. Previous could have been L, or it could have been R. So let's consider the case where the previous pointer we took was an L, right? We could either go to the left again and reset the path, or go to the right and continue the path. So what we're going to do is I'm going to, for now, I'm going to remove this later after we condense our code, but I'm going to have a return value. and initialize that at 0. And then I'm going to have a bunch of calls to max to get the return, because it's going to be the best of a couple options. So ret is going to be, I'm going to make this a little bit more verbose and then condense it. So ignore if the code isn't written too optimally right now. I'm just writing it for clarity. So ret is going to be the max between ret, which is 0, or if we go to the left again and reset the current length, or sorry, if we go to the left again, right? Previous is going to be L because we're going to the left, and then we reset the length back to 0. Or we could go to the right and extend the current path. So what we're going to have here is we're going to do the max. I'm just doing max so we get the best option between these. We're going to go to the right, and since we're starting we're continuing the path, we're going to actually have current length, right? It's being continued. Now, let's consider if the previous was R. Well, we're just doing the same thing in reverse. We could either go to the right again, right, and reset the path length, or we could go to the left and continue the path. So dfs node.left, L, current length. Now, we're just going to return the return value that we found, which is going to be the best of these options. Notice how each time we're only going to run 2. So this is just a pretty much a regular depth first search. We don't have any extra runtime really, other than some constant operations. And then for our base case, it's going to be a little bit, we have to be a little bit careful about this. We're actually going to initialize this at the root. And what I did is I just initialized it with L because it doesn't really matter, right? And I initialized it with a current length of -1. This is because we have the guarantee that there is one node at least, right? So we're not going to ever return this -1. If we had no guarantee of one node, we'd have to check up here if it's null. But once we go into this, we're going to get current length plus equals 1, and it will become a 0. And then I'm using L because it actually doesn't matter, because no matter what, we're branching off to the left and to the right with a current length of 0, right? We have a 0 here, or a current length, which is 0. So it doesn't actually matter if we use L or R or anything else for this initialization value. So I just chose L. So if we run this, we'll see that it actually works. But now that we have this as a basis, I would actually like to clean up the code a little bit once we know how this works and the logic of it, because this code makes the logic pretty simple. But it could look a little bit cleaner. So let's do, I'm going to write this out and then explain later, but essentially I'm just condensing the code. So this is our value that we're getting from recursing off to the left, which is just going to be DFS of going to the left, right? We've taken a left, and now we're going to use some Pythonic syntax. So just condensing these lines down here, we're going to have 0 if the previous was L, because remember we have to reset the current length, else current length. So essentially I'm just taking this line and condensing them down into 1, right? And similarly, I'm going to do this for right. I'm just condensing the code. The logic isn't changing. Prev equals R, else current length, right? And now we can actually remove all of this because this is just doing what we want. And then we'll just return the max of L and R. And this looks a little bit cleaner, even if the logic is slightly less apparent to someone viewing for the first time. But even if you're viewing for the first time, you can kind of see the logic of how it's working. We're resetting the 0 if we're taking 2 lefts in a row, right? Otherwise, we're continuing. And same thing with right, resetting to 0 if we're taking 2 rights in a row. Otherwise, we're extending the path. And then this line just returns the best of whichever we get. So if we run this again, we'll see that it also works. And this is a much cleaner looking solution. So let's submit this and see what we get. As you can see, pretty good runtime and memory. So thank you for watching. See you next time.